Hello students, this is Inequalities Unit, Lesson 3A, Solving Quadratic Inequalities. And I'm going to actually split this lesson into two parts again. So this is going to be part one. So when we solve by graphing, we can solve this in a graphing calculator or manually graphing. And I'm going to show you the manual graphing method now. All right, so we have x squared minus 2x minus 3 is less than or equal to 0. We are going to graph this manually using the Xavier method. So the first thing we're going to do is we are going to graph. And just to refresh your memory for Xavier's method, we get the x-intercepts first, then we get the axis symmetry, and then we use the axis symmetry to find the vertex. Another way we could graph it manually is to do a table of values. There really is no right or wrong way to manually graph as long as you're getting the correct sketch in the end. So this method, Xavier method, works really well when you can quickly factor the quadratic that is there. And we know it's a quadratic because it has an x squared into it. And it is less than or equal to 0, which is slightly different than when it's less than or equal to y. And I'll explain the difference in a second once we get through this main part. So to factor this, we need two numbers that multiply to -3 and add to -2. Our numbers are -3 and +1. So we go ahead and put them in the graph. Now imagine this was actually just a regular quadratic. That means the x-intercepts are going to be at +3 and -1. Okay, so go ahead and put those points onto your graph, +3 and -1. All right. We are then going to find the axis symmetry, which is just finding the halfway point between our two x-intercepts. So we're going to add them together and divide by 2. And that means our axis symmetry is at 1. That's my axis symmetry. Sound effects are optional, I guess. All right, and to get our vertex, we are going to substitute the axis symmetry value in for x in our original equation and find out what y would technically equal. Now, it's a little bit weird because instead of being a 0, we're going to say y equals that x squared minus 2x minus 3. And we're going to substitute a 1 in for it, for the x. 1 minus 2 is -1, -1 minus 3 is -4. So technically it would be at -4. 1, 2, 3, 4. Now, I don't actually need to sketch all of this for this particular question because it was less than or equal to 0 and not y, but we're just going to practice, the sketching part right now anyway. So I didn't mean to actually put the dot on the y-axis. It's this -4 is what y equals when x is 1. So on that axis symmetry, there is our vertex point there. It's kind of messy. Let me fix that. Maybe. There we go. All right. So from here, we can do a little sketch of our parabola. Okay, so just like with the linear, we know that our values exist somewhere on it. And again, I kind of jumped the ball a little bit and did a solid line automatically because it was less than or equal to. So step 2 would be a solid or dashed line. Because it's less than or equal to, the points can exist on that line. And the next thing is to use a test point. So just like we would with a linear inequality, we're going to substitute a test point in for x. I am always going to use that 0 test point, the 0, 0, as long as it's clear where it is. So 0 equals 0 squared minus 2 times 0. Sorry, I'm using the wrong orientation. Let me put it back to the original. And I was using equals instead of the inequality. So it was in this orientation. So 0 squared minus 2 times 0 minus 3 is less than or equal to that 0. Is -3 less than or equal to 0? Yes, it is. So this is true. So our next step, step 4, is going to be to shade, because the test point 0, 0 was true. It means it exists in the correct zone. And because we shaded between the two x-intercepts, the solution is going to be in this area. So this is where there's a little bit of a difference. Okay, so because it was less than or equal to 0 instead of less than or equal to y, it means that the solutions for this inequality exist only on the x-intercept. So they only exist in this area here because that is where y is 0. So the solution, ooh, that's not a good color to use, blends in too much. Solution is on the x-axis because that's where y equals 0. So instead of being anywhere in that blue shaded area, the solution is only in the blue shaded area that is where the x-axis is. And that's between the two x-intercepts. So the x-intercept was at 3 and at -1, and x was in between them. And it could also be equal to them. So this is the solution. So we are going to state our solution. You can state it either this way, or you can state it this way. Square brackets mean that it can be equal to as well. So that's what you do when it is less than, greater than, or equal to 0. That means the solution for x has to be on the x-axis. When it is equal to y, or less than or greater than something to y, the solution is going to be anywhere in the shaded area, regardless of whether it falls on the x-axis or not. So let's do an example for that. Y is less than -2, x minus 3 squared plus 1. So we could do a table of values for this, but the first thing we're going to do is we're just going to graph. Now this is in vertex form. And to graph this, I know my vertex happens at +3. Remember, it's the opposite p value that you see there. So it's a -3 in the vertex form. That means it's a +3 p value, and 1 is our q value. So that means when x is 3 and y is 1, that's where our vertex is. Now, because it has a negative a value, it means it opens down. So some unit review, and it opens down like that. That's all I really need to do to sketch it. Okay, so I found my vertex. I know it opens down, off I go. That's all I need. I'm then going to use that test point. Is it clear where 0, 0 is from there? Yes, it is very clearly on the outside of the parabola. I actually drew my parabola a little too wide because I know it's a -2. It should be more narrow, but even with me drawing it a little on the wide sides or sketching it on the wide side, I know that test point 0, 0 is outside. So I'm still going to test with the 0. So y is, so 0 for y is less than -2 times 0 minus 3 squared plus 1. So 0 is less than -2 times 9 plus 1. So -2 times 9 is -18, plus 1 is -17. Y is not less than a negative value. So this is false, which means the solution for this lies inside this shaded area somewhere. And I should have extended my parabola, but in here, it's in there somewhere. Okay, anywhere. It could be any of the values inside. And I made a mistake when I drew that line to begin with, and hopefully someone caught it, is that I drew a solid line. Should it be a solid line? The answer is no. because this is not equal to. So what I should have done is I should have done a dotted line for my boundary parabola. And then of course we can shade inside. Solutions in there, okay? And that is our solution area. Okay. Want you guys, I'm gonna write down the equation. So it's gonna be y is greater than or equal to x squared minus 4x minus 5. This is in general form instead of vertex form. So you're gonna wanna use Xavier method to sketch it or a table of values. Why don't you pause the video here, sketch your graph, and then use a test point and shade your areas. Hopefully that went well. So the first thing I'm going to do is I'm going to figure out my x-intercepts. I need two numbers that multiply to -5 and add to -4. So my x-intercepts are at +5 and -1. So +5, 1, 2, 3, 4, 5. Eyeballs are playing tricks on me. And -1 is here. Perfect. I then am going to find my axis of symmetry. So it is going to be 5 plus -1 over 2. So it's 4 over 2, which is 2. So that means my axis of symmetry is right here. And it should look like it goes right through the middle of our x-intercepts. Okay. And then V for vertex, I'm going to put a -2 in for the x, sorry, a +2 in for the x, that's what my axis symmetry is at +2. So 4 minus 8 minus 5. 4 minus 8 minus 5 is -9. So on this axis of symmetry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's our vertex. It's a positive parabola, so we know it opens up. So I can now sketch my graph. I'm just gonna, okay, all the way up. I'm going to use a test point. I'm going to, again, use my 0, 0 test point because I am very confident that it is on one side of that parabola. So the original inequality was x squared minus 4x minus 5. So putting in a 0 for both my x's and my y's is at is 0 greater than or equal to -5? It is greater than, so this is a true statement, which means this point is a possible solution, which means we are going to shade everything inside that parabola. If it had been false, we would have shaded everything outside the parabola. Okay, so what I'd like you guys to do is do questions 1 to 3 on page 484. Do questions number 1 to 3. Okay, and let me know if you have any questions.